Hello and welcome to this month's NoVALUG. We are having a guest speaker coming in to talk to us about Babashka um, and Clojure, which is behind it as a scripting language. So if you have ever done scripting, looking at a lot of files, looking for patterns, or just in general having data processing, this probably is the talk you want to listen to and see if there's something here you can use. So we have Rahul here, who's coming all the way from London to talk to us online. And well, the floor is yours, Rahul. I'll go on mute and just listen in. Thank you very much for coming.
Thanks for that, Peter. So thank you all for coming, joining in here. Hopefully this is a good enough introduction to both scripting, Clojure, any of us who are new to Clojure as well. That'll be hopefully a fun journey for them as well. So this is intended primarily as a Linuxy scripting-y kind of delivery, and what Clojure brings to the table and how Babashka adds to all of these, puts all of this together in a way that people who spend a lot of time in the terminal can consume it, right? So let's begin here. So Babashka, not about bashing your head in. So there's a lot of things behind the name here. So not using bash, bashing bash, or people not remembering how to do bashes. How many of us actually can write bash without looking at Stack Overflow, right? So how many of us can get that one little if else correct, right? So things like that. So that's, we're gonna start with that bit. And before that, I'll talk a few stuff about myself as well. So I am Rahul. I'm currently based in London, working primarily around infrastructure, site reliability engineering. So a lot of flavors of Linux, a lot of tearing my hair out, and a lot of scripting as well. And also I do a lot of Clojure, fairly involved in the Clojure community as well. One of the maintainers of Babashka, and try to run Clojure in weird places. People, if you have a place that we can't run Clojure at, please let us know. We'll be most happy to run Clojure there as well. A lot of stuff here in the thing as well. I go by Lispy Clouds on the internet. You can look me up on Twitter, GitHub, especially if you're interested in getting involved in the Clojure community, open source contributions. I'm happy to be the point of contact. Right? Any other things on the slide that makes interests you, I can go at length, being emotional on any of these topics here. Right? So happy to chat on that. Right? So how many of us are new to Clojure here in the call? I mean, I'm seeing a couple of people, Paula especially, who's not, Paula Giron. So apart from Paula and Timo, how many people are new to Clojure?
Audio now muted.
I am.
All right. Anyone else? Maybe like we can get a count approximate. I want to tune my expectations a bit.
I'm a lurker.
Right.
Roger.
Okay. Right. So I see two people raising their hands. Right. So I'll go through it like a quick crash course kind of style. So that we are getting used to the way like we generally program in Clojure, generally think in this language, and where it could improve us when we are writing code. Right. So a bit about Clojure itself. So it's designed to be hosted upfront, saying that it's not something that it builds its own scripting runtime, whatever it is. It tries to hook into something that's pre-built, that's there around for a while, like the Java virtual machine targeting JavaScript, or even the common language runtime CLR.NET. So all of these things are targets for Clojure, and Clojure tries to be running with it. Or it's a weird way of looking at it, but that's how Clojure chooses to be, and there are reasons for it as well, right? And the important bit is it's a Lisp, so a lot of historical heritage. The thing it adds to the Lisping community is, or the Lisp style is being as immutable as possible, as functional, or not changing things, right? So, and the new fact is it's data oriented as well. So there's rich support for data oriented programming and things like that, right? And so we'll switch over to a small run through of how Clojure looks like, how the layout looks like. So here is a project here. So if people who are familiar with Java or Java style projects, you can see like a familiar pattern here, like src test, and we namespace our things here. So we'll try to run this bit here. So before we going into that one, I'm gonna reset my editor a bit and start a thing called as a REPL. So are people familiar here with the REPL? The read eval print loop. You might have heard it in other language contexts, right? So can anyone say like what when I say REPL, what do they mean? Right? Anyone has an idea?
Until something is true or false.
Right. So console or shell or something of that sort, right? So where we can try out some commands and see what's going on, right? So I'm gonna make a bit of difference in the Clojure REPL as well, saying that this is not just a way to like trying out some things and see if they're working or not, or small snippets of code, but let's embrace the whole thing through the REPL. Let's make the entire thing live, right? So here I've started a REPL, and unlike I started in a particular way, you don't have to worry about the details of how it started up. The difference being you didn't get a prompt, you got a socket back or a port back, right? And it tells you that something can connect to it, right? It says that it's listening on localhost and that port. So let's go ahead and try to do that as well, right? So I'm going to open my editor again. No. Yeah.
It might be on a little bit on the small side.
Yeah, I'm increasing it again. Hold on. I lost my mouse there. 22. Okay. So hopefully this is better. Right. So here, if you see, you can see that it has connected to something on that port, right? So that's the first difference we are seeing from the way we normally program. We write some code, we build some things, we send it over to the compiler, and we try to see the output, right? But here, what I did is I started the REPL, but instead of trying out some expressions, I started it on a port, and my editor here has gone ahead and connected to it, right? So that's the normal way we do things here. So what's the advantage, you may ask right now, right? So I'm gonna open this thing and put it to the side. So whatever I'm gonna do, you should see like a durable log of it here on the right hand side. So I am here. So this is a declaration of a namespace saying that I'm at NoVALUG. I'm writing an app. It's a very simple program which just takes two numbers and adds it, right? So that's how you define a function. You add these two things and then just evaluate and see the results, right? So what I'm going to do is send this entire thing to the REPL, the whole file, the contents of my buffer to the REPL. And now my buffer is aware of things saying that, okay, I know of these certain functions now, right? So let's see if my add thing works well now. So I'm going to send only that bit to the buffer, to the REPL, and instantly I can see an answer there, right? So think of it as you typing the thing, but instead of you typing it, your editor is sending stuff over to the REPL, right? So that's the first aspect of Clojure or Lisps in general. Now I'm going to change the meaning of add and then send the new thing, and now the thing changes, and notice I haven't saved the file, right? So it's all a live interaction, and then we keep on talking to the existing thing and then keep on building and keep on changing stuff, right? So this is the first bit that I want to emphasize when writing Clojure, regardless of Babashka or the JVM or whatever, is you should be live, you should be interactive, you should be building the things while they're running, or there shouldn't be a difference between compile time and runtime, right? It's all the same thing, right? So that's a big deal about Clojure, and that's something that I'm emphasizing you all to embrace as well. So add is fixed now. If you send that thing, it works correctly, right? So let's see a bit more driven example, right? So here is a function which takes a number and just prints it out, because we are running on the JVM right now. So we can call the Java functions. So we say thread.sleep, thread/sleep means it's a static method call. So I'm going to print that bit and sleep for 1 second, right? So let's send that to the thing and let's see how it looks like, right? So it says hello world and counting, and after a bit you see this nil thing coming. Nil is, you can think of it as a Java null, but it's more like the Lispy nil, like the nothingness, or I can't answer your question, right? So given all of that, so we say that this works. So it print a number, you see that output there, and then after a while, after 1 second, it comes back, right? So what I'm going to do is create a future. So what is a future? Futures creates a thread, takes a bit of code and pushes it onto the thread, right? So what this bit of code does is looks up the definition of, I'm not going into too much specifics, but just overall high level thing. So look up the definition of print and wait. That's what var means, current definition of print and wait. Take an infinite range and call this function on each of the number of the infinite range, right? So because Clojure is lazy, you can't deal with a lot of infinity stuff, right? So what essentially is going to happen is we're going to start at 0, 1, 2, 3. I'm going to count up, and each of the numbers we're going to send it to print and wait, right? So you're going to see 0, 1 second, 2, 3, 4 every second, right? So let's start that, and you should see an output coming up on the right side, right? So you see this, it's counting up every second, right? So now again, so how does Clojure makes this even more better, right? So we say that's too slow for me. I'm gonna speed it up a bit. So I'm gonna sleep 500 milliseconds now. So now here's a magical bit. I'm not gonna restart anything. I'm gonna inject this live, and you see it has sped up, right? So I haven't saved the file, haven't changed anything, I haven't restarted anything, and now I'm building the thing that I want to be in while it's running. There's no loss of context. This is the live expressive power of Clojure or Lisps, right? So I can even go ahead and change, like say hello world and counting up, right? Let's inject that as well, right? So if you see the state is there, we are live changing running stuff, right? So that's what we want to do. So we are happy with it. And now we say, okay, let's cancel the feature. Now we're done. Okay? So there's an example of how we generally think or develop code in Clojure, right?
Does this kind of a process slow down the running a thing? Because the interpreters sometimes do that, particularly Lisp. You know, I use Emacs a lot, so
Right.
So Lisp tends to be real slow. The interpreters are, slower. Is this true with this too?
So we are running on, it's a good question in terms of comparing what Clojure brings to the table, because it's hosted on the Java virtual machine. So you get all of the performance, speed, tuning, just-in-time benefits of the JVM as well. So it is being interpreted, yes, but it's built in a way that it will emit the same bytecode as like you get from a Java program, and you should get pretty much the same performance as you do in Java.
I see.
Right.
And does it actually compile on the fly if you change something, or how does it?
It is compiling on the fly. It looks like it's getting interpreted, but it's everything that you send to the REPL is getting compiled to bytecode.
I get you.
So because of the way the JVM works, you can send bytecode at it at any time, and it can change its state of what it's doing. Okay? So Clojure is just making use of the hard work done by the Oracle or the people who made the JVM what it is. Right? So yeah. So why I'm emphasizing on all of this is the fact that this is how you should be writing code. This is how we should be doing things when we are building, right? So there shouldn't be this loss of connection between, okay, now I'm building, now I'm compiling. I have to wait for the compiler to tell me something, right? So given all of that bit, so you can also, if you set up your editor correctly, you should be able to get like some help from the thing as well. So Clojure or the ecosystem around Clojure has been quite active with this tooling around Clojure, saying something like the language server, the linting. So all of these bits have been built around the ecosystem, and if you configure an editor well enough, they should be able to talk to these things, and you should get like live feedback of what's going on, what's things. And if you can also imagine like Clojure being a dynamic thing, so these things keep up with your changing code as well. So take your time, set up your editor, and it should pay off pretty well enough, right? So that's how we do Clojure. And how do we do a unit test, for example? So we have this small test here in the same spirit of the REPL driven thing. So I'm gonna run this test directly in the thing which says that, okay, it's true. So which means it passes. But then here, if you want to run it in the CI, for example, like something that you push the code in. So here we say, so I'm going to look up the test one, and I'm going to run the test. So this is the Clojure command line tool, and I'm invoking the test, and it runs the test there. So similar to what you're used to in other scripting things. So what happens if you fail this bit? So you're going to see like some usual error that you expect out of it. So if you see this lag here, that's the JVM booting up. So Clojure is not the fastest of things to boot up. So we'll get to that bit as well. So that's how we build things, and we add mostly, I'm not sure if test-driven development and REPL-driven development is what we call it. They are like kind of like cancels each other out at places. I have this feeling like we like to do test-driven development because the feedback is too long between when we write the code and see the change, right? So that, but then you might not need it that much here, right? So that's that. And a quick look at the dependency thing. So that's how we declare dependencies on it. This is necessary for the next bit of the thing. Don't worry about it. But here we say that here is test, and while running the test, we can depend on a test runner. So the thing that actually run the test, right? So you can have main dependencies of your code, and as well as test time dependencies, build time dependencies, stuff like that. So Clojure brings its own way of dependency management, and you don't have to like install anything extra there. Okay? So that's that. And now if you want to execute this thing directly, someone had a question, sorry. No, okay.
I didn't hear anything.
Right.
Anyone, you know, are you okay if someone interrupts? Do you want?
Yeah,
us
please.
to...
Sorry, I should have said that. Like, feel free to just have a question at any time. I'll be happy to take it. Right? How do we run this thing from as a main, like a full compiled program? So we define the main here, which is a Clojure specific way of defining it, and here you get like the command line arguments, right? So we can run that bit directly from the thing, saying that using the main thing, find the main function in this namespace and invoke it with 4 and 5, right? So you see the output coming up, and important bit here being that time that it took, right? So what I'm getting to is Clojure, it's a great language to do a lot of interactive programming. When you're happy with it, you ship the final thing, that's fast, but it's not great for scripts, right? So for scripts, what's the idea here is we want to do our stuff as soon as possible, die as soon as possible. And scripts are generally like long, short running things, right? So that's not what the JVM was meant for, right? Right, so coming back to the thing, sorry. JVM is slow, right? So it's slow to start, but it has its reasons because it's built for long running applications. Long running meaning it can be optimized over time. It can be optimized at runtime based on the behavior of the application, right? So that's the idea of the just-in-time compilation. That's something that's the JVM is pretty much the industry standard right now. So Clojure targets all of this with the expectation that you don't care so much about the startup time, but you care about expressiveness and performance over a longer period of time. So that's why Clojure shines at being at any place where you could write Java, you could also write Clojure as well. So, but then how do we get around this time, right? How do we get it's a brilliant language, but we want to write some scripts at it because of the pains that I mentioned in the beginning, right? I don't want to go to Stack Overflow. I don't want to install 50 things to get my things on it. So introducing GRAL VM. So before going into GRAL VM, I want to show like what effect does that have, right? So what I'm going to do is replace Clojure with Babashka here. Ideally, it should work with the exact same thing. And not that, right? So I'm going to say, instead of Clojure, instead of using the JVM, use Babashka to run this, right? So hopefully that works, and that's pretty much instant. You see that time difference here, it's about 2 point something seconds. That's like 1,000 times faster there, right? So these are the speeds that you expect out of a scripting thing, right? So it starts up as soon as possible, does your thing, and dies as soon as possible. So not just the time, but the system resources as well, right? So it's way less CPU and RAM consumption as well, right? So the important bit is Babashka can be just dropped in most places, and then it should be able to work with your code as well. So I didn't change anything in the code. I just asked Babashka to run it. So what is Babashka? Before going there, we want to talk a bit about GRAL VM itself, right? So GRAL is this project from Oracle Labs. It's been running for a while now. It is like an umbrella project started with the intention of improving the abilities of the just-in-time compilers that we had on the JVM, right? So initially, we have these two C1, C2 compilers, and they do their job really well, but it's a nightmare to maintain them being C++ and C and below, right? So it's quite a challenge to maintain them, quite a challenge to improve them as well, right? So GRAL VM started as an experiment to see if the just-in-time compilers can be written in Java itself. Can we do some better way of decoupling the JVM in a way that parts of it can be plugged in, right? So that's how they came up with GRAL, the just-in-time compiler, as a plugin to the JDK. So since JDK 9, you can plug in this new age just-in-time compiler to it as well. So that's one of the idea, the GRAL JIT. And it does a lot of stuff like being able to interpret non-Java languages as well. And the other bit is native image. So given all these improvements, we are in a position to compile the Java bytecode ahead of time into assembly, because essentially that's what the just-in-time compiler does over time, but we can compile it ahead of time as well. So if we are able to generate bytecodes, we are able to get a native image working, right? So the same way we do C, C++, Rust, Golang, right? Ahead of time compiling, right? So that started as GRAL VM, but now it's reached to maturity that it could be used in a lot of places, right? So we're going to use this native image bit here. So let's see how can we speed this thing up here, right? So here, I'm going to switch here again. So I have downloaded GRAL VM in my downloads. Hopefully it should be there. GRAL VM, sorry. My phone's ringing, sorry. So GRAL VM is here. So it's a standard distribution that you have, like any of the JVMs here, right? So that's installed there, and let's see if we can make this thing as a native image, right? So I'm gonna ask my Clojure thing to build me a jar. So jar, for people who are new to it, so we take all of the Clojure code, compile it ahead of time into bytecode, and then package it into a jar, right? So if you see here, so it has created this app.jar here, right? So how do we run the app.jar? So we say Java jar app.jar 3 and 4, right? So let's see if it has done anything better to the time already, right? So now the compilation process has already happened. We have bytecodes now. All that the JVM is doing is executing the bytecodes, right? So compared to the full Clojure time, we have already improved quite a lot here, right? Just by compiling Clojure to bytecodes ahead of time, right? So we want to get it down even further, right? So how do we use GRAL VM right now, right? So I'm gonna call native image. I'm just gonna search it here, right? So here is how we compile this ahead of time into things. So we inside the GRAL VM, we have native image, and then we say, here, compile this jar for me, right? So what I'm also gonna show is the consumption that it does. It's quite an involved process of compiling this. So you can see my CPU spiking, there's 16 cores spiking at the same time. So it's a great way to warm up your room as well, right? So, and it's not a fast process, because what this thing is doing is figuring out every possible calls that you're making. It needs a closed world analysis of what it wants to do, because it has to compile to assembly. So it has a lot of magic in it, a lot of research went into it, and we have a completion now, and my CPU is back to normal again. Okay? So you see there's like a massive spike there. Okay? So compiling GRAL, not for Raspberry Pis, if you want to take something away from it. Right, so we have that, and now we see this thing here. So let's see file app. So it's a 64-bit like ELF standard executable file. So it doesn't, it's not a jar anymore, right? So it doesn't have any, so we call that and we time that as well, right? We are at 4 milliseconds now. So that's how we are speeding up our execution, right? So we say we build our, we had some Clojure code that took a while to start. We want to write some scripts. We learned about GRAL VM. We built an app, the jar file of it that already is better, but then now when we compile it to native, this is way faster than Python itself, because it's as good as a C program right now, almost as good as C program. Right. So till now, are there any questions on the whole process? This is like the first end of a first, let's say, part of the thing. I guess not. Okay, so we're going to go ahead. So now we have a way to speed up our Clojure programs, but there is a lot of overhead in compiling them, as you can see. Okay. So this is where Babashka comes in, right? So we want to fill this gap of our need to script things. We want to use Clojure because it's a nice thing. It's a nice experience that we get in building stuff, and we don't have to go and look at code all the time, and we tend to remember how to write Clojure, right? So can we fill this gap with Babashka, right? So what is Babashka, right? So it is a single binary thing that comes in as a fully prepackaged standalone binary, and you can just put it somewhere in a path and it should be able to run. So think of it as what you do with Python or Ruby or Lua, right? Important bit is it's optimized for starting up as soon as possible, do your stuff, right? And it is quite decent performance. And if you think about it, it will not have the same performance as the JVM, right? Because you don't have the just-in-time compiler anymore, right? So it works by interpreting your code. So this is where actually it's getting interpreted, right? And tries to just go through your code, do your stuff as soon as possible, right? Works with a lot of Clojure libraries. We have better compatibility more and more nowadays, right? So how does it actually work, right? So it unlike the JVM Clojure, it is interpreting your code. It is walking through the whole parse tree that you have. And the thing that powering it's called the small Clojure interpreter. It's built by the same person who built Babashka as well. So it started off elsewhere, but then you realize like we could have a proper scripting environment, proper interpreter for Clojure, right? So we can get all of these improvements that we got by compiling things to GRAL, native, and then so we can extract this bit of code and then make it into a general purpose interpreter, right? So that's how Babashka is built. You take the small Clojure interpreter, which is written in Clojure again. It can target JavaScript, it can target the JVM, it can target the GRAL native as well. So we put some opinions around the SCI, and then we finally arrive at Babashka, right? Among other stuff, it gives you this ability to, let's say, run more random pieces of it. This makes it more Lispy, if you want to look at that way. Like Clojure, after it's compiled, I mean, you are kind of in a static environment, but Babashka or SCI in general lets you be dynamic at weird places, right? Right. A lot of stuff is powered by SCI, right? So NBB, Node Babashka, not Babashka, we are still not sure what to call it. So it's the implementation of Babashka-like scripting on the Node.js platform. So you can use Clojure script instead of Clojure, right? So if you, it has a bit less restrictions like the JVM, like Babashka, for example, because you can't do things at runtime, or you can't load Java, for instance, which you can on Clojure, right? So NBB, you can use any JavaScript library that you want. So it might not have as much, let's say, multi-threaded performance like Babashka, but it's better in the other way. So they're both like complementary things of each other. So all of these links are also there. I'm going to share the slides at the end as well. OBB, you can script your Mac OS. It has a JavaScript engine as well. CLJ Condo is like one of the most popular linters out there for Clojure. That's where actually SCI started as part of CLJ Condo. And now it's a more general thing, right? Spire, you can check it out. It's people like me who hate YAML. So that could be a thing that gives some people some joy as well, right? Right. So
I think there's a question.
Sorry,
Maybe
yep.
Thomas wants to go off mute and ask.
Go ahead.
Oh, sorry. What is the difference between Rust and Clojure? If you can just pick some random.
Rust, as in the language, Rust.
Yeah, Rust.
Okay. So Rust is like a full language that's built for systems programming primarily. I mean, what all other languages are you familiar with? I can maybe draw a parallel there.
Yeah, I'm familiar with C#. I'm familiar with Python.
Okay.
I'm not fully familiar with Clojure and Rust.
Right. So Rust and Clojure, they are built with two different problem sets in mind. So Rust primarily, when you want to build something that is running directly on the hardware directly. So for example, if you want to run Python or if you want to run C#, you need to have the .NET runtime with you, right? When you want to run C#, right? So it's a managed language. It has a garbage collector. It takes care of your memory, right? So Rust is built for places where you don't have these things. Like if you want to write the operating system yourself, right? If you want to have some code that's running on a microcontroller, right? So where you don't have a memory managed environment, that's where you use Rust, right? Clojure, on the other hand, is built to run on a managed environment primarily, right? So for example, the JVM or the .NET runtime, right? So Clojure is much more, let's say, abstract, relies on the fact that your memory is managed. You have a garbage collector, right?
Yeah, good.
So that's basically the whole difference, but because the problem statements are two different things, what Rust wants to solve, what Clojure wants to solve, right?
Yeah.
Right. So yeah, and if you're familiar with C#, you could try out Clojure CLR as well. That's Clojure running on the .NET VM. Right. So I'm going to show a smaller demo again, right? So here, I already showed you like how Babashka thing works, like just replacing pretty much the Clojure call with the thing. So I'm going to kill this REPL now. And I'm going to disconnect here. Disconnect and your connect. And now when I connect, when the REPL is not running, it should go ahead and connect to a Babashka REPL now. So now instead of talking to the JVM REPL, we are talking to the Babashka REPL. So Babashka has been started automatically in the background. So what changed here? Nothing much actually, right? So we're still able to evaluate things, just that it's no longer running on the JVM, right? So we are able to do the same exact thing. And Babashka, this is Babashka interpreting stuff, right? So what can we do in like special about Babashka as well, right? So Babashka brings in this ability to like bring in other stuff as well. So I'm going a bit ahead here. So this bit, I want to talk a bit more here and then maybe go to the thing here, right? So we want to talk about the pods bit especially here. So how do we extend something that's static like the Babashka interpreter, right? So one example is SQLite, the embedded database, right? So we need the JVM to be able to load the SQLite library, right? So that's the way it's been built. So these are some of the things that we can't really do well in Babashka. Babashka has limitations. You can check out the list there as well. So how do we get Babashka to do a SQLite thing, right? So now that we are connected to Babashka, so we're going to load this thing called as a pod. So pod's something that it's very specific to Babashka. What is a pod? It's a way of bundling your non-compatible Babashka code into a thing that Babashka can talk to over the standard in or a socket. So think of it as a remote procedure call mechanism. So that's how we are extending Babashka. I can do certain things. I'm going to write a pod for it, and Babashka is going to manage it now, right? So here is a pod, which is interestingly written.
That's board, a BOARD?
Pod, like a POD pod.
Oh, pod.
Pod, sorry.
Oh,
It's my non-English accent coming up. So pods, right? So if you think about it, if it's a thing that's talking over the sockets or standard in, so it doesn't need to be in Clojure anymore, right? So it could be whatever language, right? So here is a pod that we've written in Golang actually, which does all this SQLite stuff. Not only don't you need SQLite on your system, this thing can do all of this stuff in a self-contained binary as well, right? So you don't need to install SQLite as well, right? So let's see how that works, right? So we have evaluated that bit of code. So now that we are in Babashka, it's running. This wouldn't run on the standard Clojure JVM unless there is one more library. So let's do a select 1 as sum. So it's a simple select expression. See if that works. So now you see a row being returned as the Clojure vector. So you see SQLite is running there via Babashka through the pod, right? So this is Babashka's extension of things that you may or may not be able to do it, right? So let's go and create this table as well, right? So you see a bunch of rows got no rows affected, but there's this table that got created in this DB here, right? So let's insert some stuff. There is a row that got affected, and let's see its effect here. So SQLite that tables, you see foo there, and then select. You see the row coming up here as well, right? So let's maybe put in one more thing. Okay, so that's there. And the other one here is coming up as well, right? So if you see this live thing is still there, right? So we swapped out Clojure, we have Babashka now, and then we are able to do things much faster from the scripting sense, right? So Babashka can also execute stuff directly here. So we say some things. So print ln. You can pass it some Clojure here. Right? So you say that's getting executed as well. So you can pass in a script, you can pass in a file, you can connect it via the REPL. So that's how we generally do things here, right? So I'm going to switch over to another repo with some example scripts. So here are some random scripts that I have. So let's say we're going to play this game, right? So do I have Yeah, I'm going to remove this file a bit. So here is a Babashka script that tries to guess an animal that you're trying to think of. So I thought of a tiger. So it's not a dog. And then does it have shapes? So tiger. No. So now when you run the thing again, yes, no. Now it knows that now it has learned the thing. No, right? So yes, yes, right? So it all saves this in this brains file here. So you can see it's something that you write a script for. It's a fun little thing. But then just to demonstrate, like you can do small scripting things and then you build stuff up, and then we'll go into more serious stuff later on as well, right? So everything's like you expect a scripting language to be, right? So all of this is there on the slide as well, right? So that's how we generally deal with Babashka. We write some stuff. We can use it as a project. We can do whatever, right? So what the other thing that Babashka adds in is this ability to declare a project. So BB Eden file, EDN means extensible data notation. So that's, think of it as Clojure that's not executing pretty much. So Clojure is pretty much data all the time. Okay? So we say that's our path there. So we want to deal with the things in the source. Here we can declare pods. So for example, so how pods used to work, when I say used to work, I mean like since the last couple of days, there has been a good enough change as well, right? So used to work in a way that you had to download the pods at runtime. Now you can declare them upfront in your project, right? So Babashka will make sure that it's downloaded. Right? So it saves you a bit of time there as well. So it's a fair new bit of development that we've been doing at Babashka as well. So here, apart from pods, what we saw, the SQLite thing, here we have an ability to declare some tasks. Who here likes make files? Right? Again, the same problem. We can't write a make file without looking at stack. and don't get us started on the tabs in the make file, right? So that's another thing there, right? So instead of all of that, we can declare some tasks. Right? So he said that here is a way to start the REPL, do some Clojure stuff. Here is a way to test it. So now I've been doing Clojure tests. So instead I can say BB test. Right? Sorry, wrong place. BB test. Right? So it does the same thing that we were doing there, invokes the JVM and whatnot. So you can hide all your big long Clojure invocations behind Babashka as tasks. So these are easy to think. So we can also ask Babashka to list the tasks. Nice documentation there as well. You can ask Babashka to autocomplete things. So you can see these are the tasks. Right? So these are some useful stuff that you can do the things in. And also you can hide all your huge native things behind Babashka as well. So the big command that you saw, I'm hidden it behind this native script. Right? You want to clean up your stuff, like make clean. So Babashka BB clean. Right. So, and one other thing here is Babashka can run the tests as well. So it's a bit different way of running it. The same test, but the way you run it is a bit different. So we say BB test BB, right? And you see it's instant. It didn't spin up the JVM, right? So it ran the tests in Babashka. So the idea is Babashka complements this whole Clojure setup that you have nicely, fits into the places where you see a deficiency somewhere, right? And then use it as a way that you normally script. You write Bash, you write Python, you write Ruby, you can now write Clojure because of the whole GRAL VM thing that we talked about. Right? So now it's enabling us to have a mechanism here as well, right? So we talked about tasks, we talked about pods, talked about the project, the whole BB Eden setup as well, right? So it's a more structured way of doing things, and you can declare some dependencies as well, and Babashka will make sure it's all downloaded and present, right? So that was all the demo there. So we are at a Linux users group. I'm going to show you some hopefully details here, and then hopefully it's not too much details, but I think people here have an appetite for it. So let's see where the Linux users group parts comes in Babashka. So that's Babashka on GitHub, right? So a lot of stuff. John here tried to compile it, but then that wasn't very easy thing to do because Babashka has a fairly complicated build process. Right? So it has a lot of stuff here, but the important bit is we run Circle CI as our CI. So why I'm telling you all of this, because we definitely need some Linux love here. If someone's up for contribution, this is a great place to start. You don't have to deal with Babashka's internals at all, but the way we build it, it has its dragons in it, and we have a lot of improvements to do there, right? So here is a declaration of the CI here. So we don't want to go into too depths of it, but I want to show you a few examples of the things. Right? So we don't like bash, but then there's unfortunate bash in Babashka's build process itself, right? So this is an example of how we build the Docker images of Babashka. We do a lot of jumping around. We have buildx commands. We have to figure out which platform, whatnot. This is a prime candidate to be rewritten in Babashka.
Sorry,
right.
Rahul, can you improve? Can you enlarge the font a little?
Right. Sorry.
Thanks.
Right. So this script here, which has script Docker, this is how we build the thing here, right? A lot of magic here, a lot of stuff. I, for one, have no idea what this line does. It was a contribution here. I was part of the reviewing thing, but I mean, I'm joking a bit.
Help
like,
if you want to.
I have to figure out like what this does by running it, and then like this is.
It's related to the next line.
It is. But so I wanted to say it in a way that if I see this thing in one go, I have no clue. Like I have to pause and think about it.
All it basically does is read a file, and for every comma, it separates into an array in Bash.
So here, like I said, the group here has an appetite for fixing these things. So a lot of scripts in Babashka are fairly complicated. We essentially build binaries for all the platforms, and then we try to bring them together and then build like 3 Docker images for 2 architectures, and then we distribute all of that together as releases, right? So have a look at how Babashka gets built, and the important bit is the static link bit of it. So not only we produce Babashka as dynamic linked AMD 64 bits, but we have a static bit there as well. So I'm going to quickly show you how the static thing works. So script compile. So here you see the native image getting invoked there, and here is some bit about static. So we link with the muscle library, if people are familiar with the muscle library here. So that's how we get the static thing going. And here is again a fair bit of complexity. We have to tell GRAL that, oh, you do this, you don't do that. And then we have to set stack sizes, for example. There's some, while building Babashka, you run into GRAL VM issues as well. So there are fair bit of complexity here. And if someone has better ideas, someone knows a much better way to do this, PRs are most welcome. This is a part of Babashka that needs a lot of gardening. Right. So that's there, and this was purely me being involved at these parts of Babashka more than the let's say the interpreter part here as well. So this is something that I'm like acutely familiar with and face the pains as well. So some help is always nice, right? So that's how we build the thing. We go through this whole process that you saw with GRAL. We take a CI, we build it together, and then we finally have this one single binary. Okay. So I'm gonna start concluding now. So all of that you saw would be available as links here. Primarily the Babashka book. That's a great source of information. All of it is put together in a nice organized, searchable way as well. And Clojure itself, have a look at it. Hopefully I generated some interest in the language, and especially from the scripting bit. And if you look at not for like if you don't want to consider Clojure as a long running thing, but as a scripting thing, it's very liberating. It's a really nice way of doing things. So at the end of this, I'm gonna do a small live scripting thing as well. Hopefully it goes well as well. So we'll try to build something more useful with Babashka. But then the idea is you be live, you write code and you eval things, you do whatever. Right?
Rahul, let me add something.
Mhm.
For those people who are watching online, Rahul's slides are posted on novalug.org on the presentations page, so you can see these links that he's showing on the screen.
Okay. Thank you for that. Right. So
And
all
I
of
will
that.
point out that because of the word Babashka doesn't seem to be useful for a lot of other things, just searching for it gives you a lot of good links.
Mhm.
But just using one word, so that's an easy thing. Good name, good project name.
Yeah, I mean, a lot of thought went into the name as well. Yeah, I mean, you should talk to the creator who has a lot of things to say about the name. Yeah, so the book being the primary source of truth, I want to say. So all the stuff's there, and at the end, I just want to do a call out to
How old is the book?
as old as Babashka. When did it start? 2018.
No, but I mean, I mean, is it updated frequently so that?
Okay. Yeah, it is updated in conjunction with all the changes. So they all go as a singular release. So whenever something changes, the book is updated. So I just want to do a huge shout out to Mikhail here. So he's the one who created Babashka and all the other stuff, and like pretty much half the things in the Clojure community. Extremely busy, hardworking, lot of churning things coming out from him. So consider supporting his work, and genuine person to know and meet and be a part of the maintenance team as well. Right?
And I will say he responded to me within a couple of hours.
Yeah.
When I reached out. He was very, very fast.
Yeah, I mean he's inhuman in a lot of places. So it's like I don't understand how does someone get so much efficiency. So it's like yeah. So consider supporting Bug Dude in a lot of places. So that's what I'm gonna ask here as well. And I'm gonna end here. And there's one more live thing after this, if people have time and appetite for it.
Cool. Absolutely.
Right?
Yeah, I would say one of the things that really intrigued me when I found the project was, I mean, I do a lot of file. I need to fill out a file. It may be a JSON file, or good forbid a YAML or something else with a structure. I need a small portion of that, and it's like for every type of file, it's a different. If it's a different script language, it's a different way of doing it. And it seemed like this may be a way of killing a lot of birds with one stone. So if you have something to help, for instance, how would you go in and filter a JSON file or something else? That would be great, because to me, that's one of the use cases I use a lot. I love the database idea, but it's more on the more primitive side, because that's where org, bash, Perl, and all the other guys come in, and JQ and whatever else we have available these days, right?
Yeah, I mean that could be a very like useful thing to show off as well. Yeah, I mean, so the demo that I have is for trying to talk to a server and trying to figure out like something with the images as well. So that has some.
As long as you get a stream of data and you're filtering it out, that's pretty much all I'm looking for.
Yeah, I mean that's a fairly easy thing to do as well. Maybe I can just quickly show you an example right here. So for example, this. So here is where I'm piping the output of ls into Babashka. And then saying that, so here is a bit of Clojure code. So this stands for read from the standard in, right? So from the standard in, filter out all of the things, change it to a file, and if it's a directory, filter them out. So you're going to get only a list of directories out. Right, so it is a bit of a involved bit of Clojure here, but then it plays really nicely with the other tooling as well. So you can use it as a Unix piping thing in a lot of places, right?
Can you do it in Babashka without the Clojure parts of it, or?
So Babashka is an interpreter for Clojure. So
Right, but I mean, do you have to then know Clojure to write this?
yes, so this is the current target for Babashka is people who are familiar with Clojure and who want to write scripts as well. Right, so that bit is a bit of a, let's say, prerequisite. So the idea is we all pick up Clojure as a thing that we want to try it out, and then
Just a dumb formatting question. That arrow you have there, is that just because of GitHub interpreting 2 dashes to an arrow, or?
Yeah, it's a font that I've set. It's a ligature thing going on. So I've said, like, whenever you see a code block in GitHub, use ligatures. So ligatures is a way of like, for example, here in my editor, if I type out an arrow and it looks like an arrow. So
yep.
So it's the same thing going on inside my browser. I just told my browser, like, whenever you see a code block, so use that font and make it look nice.
Okay, I'm just, when I look at that as someone who may not have your setup, I would go, where do I find it? I mean, I know how that usually comes up, just like you typed it, right? It will automatically translate it. But if what I need to type is -- greater than.
Yeah, that's how you're gonna see it. It's just my browser interpreting it differently.
Yep. Cool.
So yeah. But yeah, I mean, John, to your question, it is the expectation is, yeah, I mean, you're familiar with Clojure, and then you're scripting as well, right? So here is the other way around as well. So you can pipe some Clojure data into it, right? Yeah. So that's that, right? So are there any more questions on Babashka, its built, or you want to know something more about before we go into the live thing?
I'm fine. Anyone else here with questions?
Nope.
No? Okay.
Continue. Thank you.
So let's create another, sorry. No, I'm looking for that. Yeah. So I have a bunch of files here. So files and downloads. Yeah, so I have this bunch of pictures here, right? If anyone recognizes where this is already.
Holland, Amsterdam.
Yeah, so this and these 3 things. So I want to write something that figures out where these photos have been taken, right? So it'll try to print out the address of the place. And then, so let's see how we go about doing it, right? So this is going to be something that's, I think it's interesting to do. And it demonstrates, like, every aspect of both Babashka, Clojure, and how do we go do about these things, right? So hopefully this should be quick enough. So let's see. So I'm going to start from scratch. So that's fine. Let's say find CLJ. Start my editor up again. Okay. So that's my find CLJ. I have Babashka running there. So what we will try to do is this thing called EXIF tool. So let's go there. So downloads. So here are the images, and we say EXIF tool of, let's say, let's take randomly whatever. So EXIF tool is probably people are familiar with it already. So it goes and looks the EXIF data of the thing. So it tries to figure out the GPS latitude and longitude of the thing, and that's how it is, right? So we're going to use this to try to locate where the image is, right? So each of these images have their EXIF thing. So how do we do that here, right? So let's write a function that tries to get a coordinates here. So def. So here is a function define get coordinates. So what it needs is a path of the image, right? And now what we're going to do is try to shell out to EXIF tool, right? So we could either find the library that does it, that reads EXIF, or just since we have EXIF tool, we can just shell it out, right? So here is how we do a require of the thing. So we say Babashka process. So Babashka, like you expect a scripting tool to be batteries included. It has a lot of stuff built into it already. The JSON parsing bit we're going to do here as well. So you're going to see that bit happening as well, right? So we say that. So let's send that to the REPL. Okay, Babashka is happy with it. So let's create this function now, right? Get coordinates. So we say, let's see how we try to call this bit itself, right? So proc. And then we say shell out to the EXIF tool. And I'm just going to copy this because it's probably too much to type. Right, so that, and we want to add the path at the end of it, right? So string str just concatenates multiple strings together, and then we say path at the end of it, right? So that shells out, that creates the command, shells out to the thing, right? And then we say, how do we get the output? So output of it. So let's just try to run this thing directly. Comment. So this is a special thing that we do in Clojure, a comment block. It's like a comment, but you can eval things inside it, right? So how is it different from a normal code comment is essentially comment is just a function which takes a bunch of things and does nothing with it. So that's how comment is implemented, right? Why is it important? Because you can now eval things inside it, unlike usual comments. You can also check this in to other people who want to see how to run this, how to play with it, right? It's like a live documentation as well, right? So we call them rich comment blocks. So it's a bit of information there as well. So get coordinates of the path there. So let's copy that name. Downloads. And that. Okay. So let's see how this thing actually works. So what I'm trying to show here is you never leave your editor. Your focus is always on this interaction always, right? So and you're not sure how to go about doing these things, right? So it's a thing that you play with it, you figure it out, you explore, right? So so I send this bit to it. So now it knows a function called get coordinates. So you see it has some output here, and I'm gonna fix this a bit. So you see there somewhere in the middle of it, you see the coordinates there, right? And it's part of this thing. So it has given you a hash map as an output, and I want to take the out bit out of it, right? So what I'm going to do is use this arrow thing, which means that take this thing, pipe it to the next function. So we say proc message. It's the same thing. Instead of calling it to the function, I say take this, pipe it. Okay? And then I want to pull the out thing out of it. So I just say that get the out stuff out. Okay? So this is same that given a map, pull the value of the key call out. Okay? So now you see it's a bit better, right? The output here, right? So the thing here is we iteratively build towards the thing that we want, right? So at the end, we want these two things as floating point numbers. Right, so that's, let's say that's that I'm happy with it probably. So let's say, so I'm going to bind it to a variable here. So let's say that's my data. So let creates a local binding, a variable, right? So given that output, so how do we wanna like change it to something, right? So now we need some string parsing because we want to drop all of these extra things here, and this we just want these 2 bits out, right? So we need a string library. So Clojure has a string library. So Clojure.string as s. Okay. So we eval that, and then we say how do we start it? Okay, so string split. Yeah, we could split the lines. So let's try splitting the line. So if you see here, this has 2 lines here, right? So you want to get these 2 things separated out. So let's see how does that look. So now you see them in 2 different lines here, right? So you've got a vector back. This is the first element. That's the second element. There. So just a wrapping because no space, right? So we want to take each of them, drop all of this extra stuff. We want to take only this last bits out of it, right? So splitting lines is already helping us. So after splitting the lines, we want to split on the semicolons, right? To get the end part of the thing, right? So let's write it the other way now. So that, what's the difference between this arrow and that arrow? I'll come to it. So we say split lines, and now we want to map over it. So I guess people are familiar with map, filter, functional style things, right? So we have a list or a stream of things and we can map over it. So map over each of them, right? So split split that. So I'm gonna explain the syntax in a bit. No, it needs to be a colon, right? So what is the difference between this arrow and that arrow? So this means that take this thing, pass it as the first argument of the next call, right? This means that take it, pass it as the last argument, because that's how map behaves, right? Map's first argument should be the function, next argument should be the list. So we have these 2 different kinds of arrows, which tells Clojure that how do you want to pass it or thread it to the next one. You can thread first or thread last, right? So a bit of syntactic difference, but don't worry too much about it. So let's see how does that work. So we are there. So you see this splitting is sort of working already, right? It split the first part and then the second part is there, right? So we want the second part out of it, right? Right, so given that, so we want to map the, let's say second out of, so second is a function that takes a list, gives you the second thing out of it. So that's there. So let's see if we are correct. So you see we are getting there almost, right? So now this extra bit of space is remaining, we want to drop that. So we say map s trim. Trim is another function, trims out the extra spaces. So yeah, now we have them as strings, right? So this is what we essentially want out of it, right? And the final bit is to change them into floating points, right? So we want to map to, we have a function called parse double. So it takes a string and parse it into a double precision floating point. Right? So now we have exactly the thing that we want, latitudes and the longitudes, right? So we want to return this as, let's say, yeah, we can just return it as it is. Right? So that's our get coordinates function, latitude, longitude. And now what we want to do is find the a way to figure out where this thing is. So I have a sample API here. Sorry. Right, so I have pasted it and I'll try to copy that. So longitude there, latitude there. Right, so I'm going to increase the font a bit. So if you see this, if I call this OpenStreetMap API, it responds with this thing, right? So like Peter guessed, it is in Netherlands right now, right? So that's the output that we want to see here. So it's a JSON output. So that's how the raw thing comes in, and that's the formatted bit. So if you see here, we have the address, and we have the display name that's fairly accurate positioning that we get, right? So how can we use this in our code here, right? So let's try to say define a function. So we locate. So given a lat and a lon, right? So we want to call this API now. So for that we need an HTTP library. Babashka comes with that as well. So if you notice, I'm not installing anything. Here in Python, you would have needed a dependency probably, right? So what we're going to use is this thing called HTTP kit org, HTTP kit client, HTTP. So if you see, we require some like namespaces, and then we give them some alias, like a short form, so that we can refer them. Right, so that's our way of calling it, right? So lat long. So let's create the URL first. Let URL, and we're gonna call format. Format is way to format strings, pretty much. So I have that. I have this. So that's my string here. Yep, so this is good. And then we can format the lat and lon the. So that's a formatted URL pretty much, right? So let's see what our call says here, right? So HTTP get of the URL, and HTTP kit is an asynchronous library. And then so to make it synchronous, we say use this at. At means dereference the asynchronous code, or like await, right? So whenever you're doing it gives you a promise back, but then wait for it to be resolved, right? So that's Clojure way of saying that dereference or unwrap it, if you will, right? So let's see the output of it. So that, and I'm gonna copy that bit. Locate that. Yeah, I'm gonna clear this out a bit. Hopefully, yeah, you see this output here. So it's the same output that we saw in the browser. So we see this coming in as the URLs there, but then somewhere we should see the body of it. Yeah, so that's the bit that we're interested in here, right here. Right, so it's part of a map. It's a key value pair, and the value is called body, right? So we can try to get the body out of it. So same way as above, put that in the threading function, and then we say get the body out of it. Right, so this, so we just have the body now, right? So if you see it's a JSON thing, now we need a JSON parser. Babashka comes with that as well. Right? So Cheshire is the name of the library that Babashka bundles. It's a fairly well used JSON library. So we have the body, and now we want to take that string and try to parse it as JSON, right? So we say JSON parse string, I guess, and so true. let's do it without the thing. Okay. Let's see if this helps in any way. Yeah, so we have a parsed JSON as a key value dictionary in Clojure now, right? So we see this is the key, that's the value, key value, right? So what do we want out of it? We pretty much want the address bit. Let's start with the address, or let's take the display name instead. I know it's called display name, and let's go with address. Okay, so from that we want to say get from whatever came in the I hope it's called display name, because that's what I checked last time. Yeah, okay, so that's how it is. Right? So we, given an image, we're able to figure out the address now. Right? So these two are my building block functions. So now I can say, give me an image and I'll try to find it. So how do we get the image? So command line, so let path is the first of the command line args. So command line args is whatever you pass to Babashka at the end of it. So I'm going to take the first out of it. So that's going to be my path. And then we say, or let's do it a bit better. Chords. And I'm going to do a bit more fancy stuff here. So lat and lon would be the get chords of the path. Right, so this means that get the chords as a list, but also break it apart into lat and lon. Give me two variables. Because it's a list, I can break it apart there, right? And now I finally call locate the lat, sorry.
Were you meaning to break apart the first element in the list into another list?
Yeah, so if this is a list or anything that looks like a sequence, so we can say take the first 2 bits.
No, you've taken the first bit and you've broken that first bit into a pair of things. Because you've got 2 sets of.
Yeah. So yeah, that's a correct observation. Yes, exactly.
Okay, thanks.
Yeah. So that's what we want to do actually. Yeah, it's a thing to fix. I would have made a mistake. Thank you. Right. So this is saying that it is a list already, and then we want to break this apart into lat and lon, right? So so that's our thing, and I'm gonna format this a bit. Okay, so that seems to, let's put this in a form. Do you want to put this in one? Let's not. Okay. So let's see, now that we are fairly happy with our small little script here. So let's see if this thing actually works from the command line. Am I in the right place? Yeah, I'm in the right place. Okay, so BV, find CLJ and downloads, locate, whatever is the first one. Okay, I forgot the print. Println, finally you want to show something to the world. Yeah, so that's the Dutch image. Let's see where the other one is. This is north of Germany, close to Hamburg. And then the third one is south of Germany, Stuttgart. Yeah, so that's what I wanted to show. How do you do a script from scratch, and how do you go about building it? And then finally you save it once, and then you finally have a way to do all of the other stuff. This is like a very ad hoc thing that I thought of some time back. I thought it would be a good demo to show off to people.
Yeah, I like the demo.
Very good demo, yes.
Just one question.
Yeah.
Why did you prefer to use proc.sh and not pipe in the data.
Pipe. So you say we start XF tool and then pipe the thing to Babashka.
Yeah.
Yeah,
Would it
I
be
mean,
possible?
we could have done that as well. Yes, I mean that's. I mean, probably one of the reasoning here could be later on if some library is compatible to do XF, and I could just use that inside Babashka, so I wouldn't need the data to be coming in, right? So my reasoning there is like, say, I want Babashka to be compatible there or self-contained. So right now it depends on XF tool on being on the path, but later on, if Babashka can read XF directly, then we can not have this bit as well. Right? So probably it's a bit better to be self-contained than piping in.
All right.
Oh,
Roger, you have a question? Sorry.
yes. Do you worry about using something external to your software like HTTP kit?
Mhm.
I mean, is that static? Can you trust it for the
So
future?
it's built into Babashka. Right? I didn't download anything right now while running this.
Oh, that's built in. Okay.
Yeah, it is built in. So all of the stuff that you see here is coming as part of the single binary that you download. So things like JSON parsing, HTTP, CSV, and these kind of things, they're all built into the binary itself. Right. The pods bit is the part where we download the Golang thing that you saw. That is downloaded from a registry that we have. So if you trust the registry, then you can trust it. Otherwise, you can also like place it on your path.
Could you pipe this UML to get a map to come up on Google?
Hopefully, I mean,
Not today.
but yeah, I mean, you're pretty much at your disposal here. You can pretty much do whatever. So the important bit that I wanted to show here is the difference in thought process when you script in other languages versus Babashka. So you do this live thing, live, and then you save once and then you run. So you explore the thing that you're building. And then when you're not sure, you have a very nice feedback path as well. And you don't need things like debuggers or stepping points because the thing that you're building is like fairly decomposed into smaller parts.
Well, true, as long as nothing changed on you between now and so you're very much depending on these endpoints doing exactly the same
Exactly.
time
Yeah.
you call them.
That's the curse of the side effects. So,
yeah.
So as long as you're in your nice little pure function bubble.
Sure. That's true. But that was another thing. So, I mean, that might be abusing it. But all I'm looking at this thinking, could I use this in an enterprise level? And what scares me is a little bit is that you're depending on all your endpoints being available. But if it was a database and I started doing changes, I don't want to change my production systems. I need to have a way of saying I'm in a development environment right now. I'm in a QA environment. And I don't know if there's anything in here that allows me to sort of set up what environment am I in. Hence, I can start filtering. I can test things without, destroying other people's things.
Yeah, I want to say like that's a it's a occupational hazard of writing Lisps. So it's like it's something that's inherent there. So it's up to you to like I think set up the safety nets correctly, saying that okay, I'm here, so I only load this particular set of dependencies. Or so what you can do here, for example, is saying load that particular BB then only, or only these set of dependencies, or
well, that's what I'm thinking, right? I mean, typically I would have let's say a configuration file that says this is how I connect to my development environment. This is how I connect to my QA environment. Either I don't want to have anything in my code that has a static name, like a URL, username, password. So I'm loading that from somewhere.
Yeah.
So the idea would then be, is there any way for me to just pass in one parameter to say I'm in this environment, so I'm loading it maybe from this directory instead of that?
Yeah, I mean, you could do like you have ways to read either config files or environment variables here. So
Okay. Good.
the way that I go about doing it is set certain environment variables, and then they have different defaults. So that's how the projects that I've been involved in. So defaults are generally something on the local host, and the others are pointing to somewhere more useful. So yeah, I mean, there are ways to do it, but unlike let's say other more statically driven things, Lispy things don't have much opinions here. I think it's.
Okay.
I mean, you have to you have to be aware of the potholes here. So
Cool.
yeah, the idea is, I mean, you get used to the idea more and more that you're in the REPL, you're doing things, and then so that's.
So
Right.
the reason you keep giving it full path is because you're using Rebel instead of just saying use the file in my own current directory.
I could do that, but that's not where the file is. I'm here currently. That's my present. Let's see if I can print it out. Hopefully I remember my Java correctly. It's just user path, or what was it called? User dir, I guess. Yeah, so that's where I am currently.
Okay.
So I could use like something like there's a thing called Babashka FS, which gives you the path, home path as well. You could build in. So anything that you could think of as useful in a scripting thing, probably Babashka will bundle it. And you should be able to use things like unzipping, traversing, globs. So those kind of stuff, yeah. Yeah, because just because I'm not in the same directory, I'm just using the whole path just to be safe.
Okay.
Okay. Right, and you can see like it's extremely not. Yeah, probably a good thing to demo is what happens if I don't pass it. You're gonna see like the ugly side of Clojure now. So it simply tried to find the first of nothing, and then so Clojure blows up in your face. So there's no denying about it. So it's you getting used to it, you get more familiar with it, and then so that's the way I like to call it. Is like it's like playing the violin. I think there's no guides or types or anything anywhere, and then first sound you hear on the violin is like the most horrible thing you ever heard. But then you get used to it, and it's all muscle memory. Yeah, so this, I wouldn't push this into production, for example. I would write some guards around it. I would say that, have you even passed anything useful to me? I would even check the fact that, is the output an actual image? What if it doesn't have an EXIF data? So all of that guards need to be put in. So if you want to compare this to something like Haskell, Scala, it's a very different way of thought process.
So you said this was a pretty customized editor before we started out. Is there an editor out there that's already pre-configured with all the lookups, the stuff that you're showing here that it keeps helping you, what's available and all that stuff that you could say?
So what I want to point towards is this thing called Language Server Protocols, LSP. If I see if I can quickly find it, yeah. Yeah, this is a thing that Microsoft built. So it is like a editor independent way of sending project diagnostics and like project information in general, autocomplete, linting, whatnot. So so I'm using NeoVim here. So it's talking to the Clojure LSP server. So every language probably has an LSP server with it. And given whatever editor is, I think most of them now would support LSP in some way or the other. Like I definitely know Emacs, so NeoVim, why? Because it has like inbuilt LSP support. But something like Emacs, you have to download one package there, and you should get LSP support as well. But why I'm recommending LSP is because this is the most, let's say, frictionless way of getting started. And then, so if you have an editor, let's say VS Code or something, you just make sure you have the Clojure. So VS Code, I think, has something called Calva, C-A-L-V-A, Calva. And that does talk to the LSP as well. So make sure you have the LSP installed and your editor's language mode installed, and you should be good. So it's fairly painless from what initially the setup was for.
Cool, but I mean, this demo definitely was pretty much what I'd hoped to see. So to me,
Mhm.
I'm very happy. Thanks for coming. Any other questions we have on to 12 o'clock normal time? We don't have to be here to 12, but if you have questions, maybe something that wasn't directly demoed, we can talk about, or completely different. We have a little bit of time.
I'm happy to talk about random things now. I'm done with all of my bells and whistles.
And you had no hiccups with your demo, so that's pretty good.
That's yeah, I mean, that's it. This is where my site reliability engineering comes. There is a whole bunch of backups around it. So yeah. All right.
Well, if there's no other questions, I will stop the recording. And again, thank you very much, Rahul, for coming and talking to us. I would say normally we do have quite a few more people. I think we got the word out too late here, but that's on us, not on you.
Yeah.
But you are more than welcome to come back and either do a similar talk or talk about something different. Thank you very much.
Thank you.
Let me see. Figure out there we go.
All right.